Every once in a while, when I do work on a car, I'm looking for a particular problem, or in this case, want to demonstrate how to find a particular problem and to test for something, and I find a different problem I was not aware of. I call it dumb luck. In this case here, I'm working on our 1973 Mustang Convertible with a little 302, and I was preparing to show how to test for amperage draw on the convertible top electric motor. And I was first going to show where the circuit breaker is located on the starter relay. We have a circuit breaker. There is no fuse for the convertible top switch, even though the electrical diagram shows it to be fused. It's incorrect. On my copy of my schematic, I've made that notation. But in order to test this, to see if it's working and how much amperage is coming through the system, using an amp meter while I'm moving the top up and down, I need to get an amp meter around this black wire with the green stripe. And so I started to put a little pressure on here and found this thing is moving back and forth. And I can tell by looking at this when I'm moving it, it's not the housing that's moving, it's the whole unit is moving on the positive terminal, which tells me that this nut on the positive terminal is not tight. At least not for the switch. It's tight for here. So it looks like what's going on is I have to tighten that connecting nut down before I end up having problems with this unit for the circuit breaker. The other wire that's loose is right here. This red wire. This is an aftermarket wire, and it goes to the relay switch that then leads to the electric fans, to have electric fans run to cool the engine. So I'm going to try that up before I go any further, and then I'll show how I can test using an inductive amp meter how much amperage the convertible top motor is pulling, as an effort to diagnose or show how to diagnose how good a motor is or is not. Okay, because I'm working by myself without Linda, I had to go off camera to tighten up the retaining nut on the starter relay so that the circuit breaker stopped moving. Before I did that, I checked again on this big cable to see if it was loose or not, and it was. It just was partly tight, so it didn't move around too much, but it still did. So I could have had bad electrical problems with this whole car. And the wire now going to electric fans is also tight. So I got lucky, essentially. Okay, so in order to test this, there's a black wire with, I believe it is a green stripe. I need to try to get up where I can start to work with it using an inductive amp meter, which I'll show in a few moments once I get this wire. Okay, I found the wire. It's right here. I found it by pulling on it. And it looks like it's black with green hash marks, but anyway, this won't be on every car. This is on a car with electric power top motor. To test it, I have what's called an inductive amp meter. It's part of a digital volt ohm meter, or DVOM, digital volt ohm meter, and it has a clamp that I can put around a wire or a cable, and I can measure how many amp meters are being pulled through that wire, how much current is being pulled, by putting it on the correct scale. In this case here, the normal amperage is 28 amps. And so I'm going to set this to the 60 amp scale. The other thing I need to do, I'll turn the backlight on. Right now, if you take a look, this is set for DC direct current voltage. That's what you want. But you need to make sure it's DC, because it's possible that it's set on AC and it will not read correctly if it's set for AC current. So I will set this back to DC, and then you see it says it's 0.67, 0.68 amps. That's not correct. There's no amperage going through, so I have to zero that. So the same button I use in this unit, the same button I use to select the function, I can hold it down and I can zero it. And now it's showing 0.01, 0.00. So it's basically zeroed out. So what I do next is I open this clamp and put it around the cable I want to measure for. So see if I can do this one-handed. Down here, I'm now sitting around that wire, and so now I should be able to go and hit that power switch on the dash to activate the convertible top motor and see how many amps it's pulling. The problem I have right now is, once again, Linda is not with me. So what I'm going to do instead, rather than show how this works, the important thing was showing how to set it to DC and to zero it. There's zero. Before using it, it's just showing you how to do that and how this thing sets up. I have a much bigger unit called a VAT40 volt amp tester, and with that one I have a much bigger gauge to read. I can read that from the other side inside the car when I hit the switch, and I set this up with its inductive amp meter, and so that's what I'm going to do. I'll set that up and use that today. Otherwise, if Linda was here, she'd help me. So bear with me. I'm going to set this up and I'll show you how to test that electric motor. Okay, I've got the VAT40 set up. I hope you can see that needle. You're about to zoom in. I'm going to start putting this top down and look at the amps. Now I'm going to put it back up. Now, as the motor starts to hit resistance with the top going down, you'll see the amperes go up higher than what it took to move the needle and the top to begin with. That is called stalling the motor. Don't do it for very long because it's not any fun for the electrical circuit, but there is a specification given for stall amperage as well as running amperage, and I'll cover that in a few moments. The shop manual specifies that you should have 28 amperes maximum during normal operation and 40 to 50 amps maximum during a stall. Here we show 22 to 23 amps of draw with just about 12, a little over 12 volts during normal operation. In this video clip, we had the convertible top motor closing and stalling because the top was closed, pulling 42 to 43 amps, and the voltage dropped just below 12 volts. So that is normal. There's another place you can get the amperage reading from if you wish. That you can do by getting the proper socket wrench for this bezel nut, or using a pair of needle-nose pliers to carefully take this nut that's inside this bezel loose, remove the nut and bezel, and then the switch will push out away from the dash and come down. And then the power wire going to the switch and the two wires going to the power motor for electric top will be exposed, and you can take that inductive amp meter and put it around any one of those wires to see how much amperage is being carried. Now in that case, it would be good to test all three wires, one for the power coming to the switch, and then two go back to the motor. And depending upon whether you're going up or down, one of those two wires going to the motor will carry current. In theory, if one works, the other should work, but of course, we could have a problem somewhere in the continuity between the switch and the motor itself, and this amp meter will show this high resistance because the amperage will be lower than normal with where we have a bad connection or bad continuity. So you'd have to trace it between the switch and the motor and ground to find where that problem exists. The other thing you can do is get a voltmeter and make sure that you're getting voltage either to the switch and going out the switch, as well as amperage, because that'll tell you also whether you have a continuity problem or not. You can also go back to the electric motor connector itself and start testing there for continuity and voltage. And there's another test called a voltage drop, which once Linda is back, I'll show how to do that as well. But for right now, that's what we've got, and I hope that helps track down the amperage flow, current flow, to the switch for the convertible top, and then to the motor from the battery, the source of the current. This is one page of a schematic file I put together for the convertible top circuitry. This shows where the circuit breaker is located and attached to the starter motor relay.